So let's go ahead now and look at the fetch instruction. In this video we're going to see where the interface is between software and hardware. So this is really quite interesting. Good luck. So go ahead and open up the fetch instruction, which is in the resources section, and then head back down to the CPU. You double click on that and you'll see the CPU appearing. So let me make that a little bit bigger so we can see what we're working with here. So we're going to be using this simulation here, and it's very similar to the previous one, but I've just changed the connections slightly. So in this one here we're actually going to be using the memory address register, but we're going to be disconnecting the input and we'll put our own input in. There's another thing to note here is that we've got an extra couple of registers here that we've not talked about, and this is new stuff we're introducing in this video. So we've got something here called the instruction address register, and we've got something called the instruction register. Now before we get into details of talking about what they do, we can see quite simply that all this is just another one of these registers here. Exactly the same thing. So we zoom inside it, you can see that there. It's just the same as the register, so it's CPU Reg 8. And also this one here, the instruction register, is just the same as this temp register, which is just the same as this one here. The only difference is we don't need the enable section on it, so if we zoom inside it, it's just a simple memory block which we designed a long time ago. Okay, so there's nothing new in the actual structure of these, but we're interested in what they're going to be used for. So let's get inside the control section and we'll have a quick talk about what we're going to be doing here. Now this is the control section. You've seen this before. Now in the previous video when we looked at the add instruction, we've seen that we had connections in pins 4, 5 and 6, and we've seen that pins 1, 2 and 3 in that add instruction, we just had them disconnected. Now this is an interesting little possible eureka moment, because what we're looking at here is the first glimpse at the interface between software and hardware. Now the way we want the computer to work is, as this counts along here, 1, 2, 3, 4, 5, 6, these wires come down and they connect on to sets and enables. So in effect, as you see here, it's just hardwired. So if this was to count 1, 2, 3, 4, 5, 6, it would go back to the beginning again, and it would do the same thing again and again and again. Now that's not much use to us. What we want to be able to do is ensure that once it gets to the end of this count, when it gets to 7 and goes back to the beginning again, we want to reset all of these connections. So we want to change the connections, and then whenever it goes round again, we want to change the connections again. So let's have a little thought experiment. Let's imagine there's a little man inside the computer here, and his job is, at the end of this count up to 7, everything stops and he has to take the wires and he has to reconnect them onto different points. Okay, and then whenever it goes round again, it stops and he has to reconnect the wires onto a different set of connections, and so on and so forth. So first thing is that obviously you don't have a little man inside the computer. The little man is going to be replaced by some logic circuits. So we're going to have to build a logic circuit here that allows us to change these connections after we have worked through each cycle here of the stepper. Now secondly, we need to ask the question, where does the little man here, where does he get his instructions from? I mean, who tells him how he should reconnect all of these connections? So you can imagine having a second little man here, and he's sitting here at the bottom and he's saying, right, whenever it gets to the end of the 7, everything stops and this is the little instruction man. He gives the instructions to this little man here, and he says, right, change the connections of the wires in this particular format. And this little man up here says okay, he goes and he changes it, and then whenever we come round again, we get this little, it all stops, and this little man says, right, change the connections to this new format, and this little man here goes and changes the connections. So what we're getting at here is we're going to have a logic circuit here that changes, but it's going to change depending on some kind of input. Now the only input we're going to have obviously are zeros and ones. So we can see here that these instructions are going to come in to this control unit and going to tell it how to change the connections. But what are these instructions? Well, these instructions are your program. This is your program code. Of course, it's written out in binary at the moment, so you wouldn't understand what it means. So it's simply ones and zeros that come in and change the connections inside the computer. So this is possibly a eureka moment for some people. What we're looking at here is the interface between the software, which are the instructions here, and the hardware, which is the logic here, which we've still to build. So the new register is called the instruction register. An instruction register contains the program. So the program tells us how we should connect all the sets and enables. So in effect, the program tells us how we should move information round about the CPU. So what we are interested here in this video is the fetch cycle. Now what we mean by that is, where does this program come from? So where does this instruction, which is basically just 8 bits, where does it come from? Well, the answer is it comes from a RAM. So in order to run through the program, which is stored in the RAM, so it's stored in our bytes inside our RAM, we have to go and fetch the instruction, and then we have to take it all the way around and we have to put it in the instruction register, and past the instruction register just gets passed straight into the control section. So this is called the fetch cycle. So in cycles 1, 2 and 3 here, this is going to be the fetch cycle, and you could say that these cycles here, 4, 5 and 6, would be an execution cycle. So we fetch an 8-bit instruction, and then we execute the 8-bit instruction. So that's us talked about the instruction register, but what about the second register here, the instruction address register? Well, the instruction that we get is somewhere in the RAM. Now it could be anywhere in the RAM. So for simplicity here, we're just assuming the instruction is going to be sitting in the first address of the RAM. So in this instance here, if we opened up the RAM and we zoomed out, the first address in the RAM is actually this one here. You can see here that the vertical is high and the horizontal is high, and it's choosing this one here. So this is our first address, and it actually runs 1, 2, 3, 4, 5 up to 16, and then that becomes 17, 18. So when we fetch out an instruction, it runs like this, that way, and then this way. So the instruction address register, it contains the address of the next instruction that we're going to go and fetch. So I'll say that again. The instruction address register contains the address of the next instruction that we're going to fetch. You'll also hear it sometimes called the program counter. So let's look at this in a bit more detail. You see that I've disconnected the input to the RAM. The reason for doing this is that we can change the values ourselves, and these values will go into the first memory location in the RAM. So these values in effect are our first instruction, and we are going to fetch this first instruction from the memory location here, and we're going to take it all the way around and we're going to put it into the instruction register, and that will be the first instruction for our control section. And we just want to be able to change it so we can put different values in, so we can see the bus changing colour and it becomes obvious what it is we're doing. Now secondly, you'll see that I've nobbled this as well, and I've changed the set here to high. And the reason we're doing this is that at the moment we don't have any reset functions within any of these registers, so in order to get the initial conditions correct for the moment, I'm just having to put the set to a value of high. Okay, so that's just an initial condition, and whenever we work our way up the hierarchy, a reset function will be provided. Okay, but at the moment for this simulation we just set that at high. Now when that's set at high, we see that when we get into the control section, right away the instruction address register is enabled. So it means that the value that's in this instruction address register is automatically now placed onto the bus. But what controls the value that's actually coming into this bus at the moment? Well, if you get into the instruction address register here, now I'll just zoom out so you can see all the information. So at the moment, what controls the value that comes in here? It's all zeros, but I could get in here, and if I right click it, you'll see it says show attribute, and it's got pull down. I'll pull this up a bit so you can see it's got pull down behavior, so pull behavior, and it's set at pull down. Now it's set at pull down because it's really saying is when you don't know the value of an input or the value of a wire, you get an option to either make it high or make it low. So I've chosen to make the value low. Now I could get in here and I could set the pull down behavior as pull up. Okay, now if I was to do that and go back into the top level, so we're in the top level here, and I'll zoom out so we can see. Then if I was to redo this, I could reset the simulation, and you'll see that instantly all of the values here are actually sitting at 1. Okay, so we're just kind of knobbling this at the moment. We're just setting it here so that all of the values are actually a value of 0. So I'll just get in and change that pull down behavior to pull down. Okay, so we go back in here and we go into simulate, reset simulation. You'll see we're back at 0, which is what we want, because the address of our first instruction is going to be address 000. So now we've set the scene for the fetch instruction. We'll go through it in a bit more detail now, but basically all we want to do is we want to go to the first memory location, take out the instruction and put it in the instruction register, and then the stepper will run along and it will act on that instruction, and then when it gets to the end it will go back to the beginning again, and then we want to fetch out the next instruction and take that into the instruction register, and then the control section will act on that instruction, and then we want to go and take the next one, and so on and so forth. So let's go ahead and we'll see how that's done. So we're going to go through the control section here, and we'll shift the clock along, and we'll have 1, 2, 3 going live, and we'll check and see all the enables and all the sets, and we'll see how this works in order to fetch that information. Now first of all, what we're going to do is we'll change our instruction. So right now it's just going to be sitting all at 0. So let's say we put our instruction, and our initial instruction is all 1s. Okay, so in effect this instruction here is going to sit in the first memory location, then we're going to go to that memory location and take that information out and we're going to put it in the instruction register, and this here becomes the first instruction for a control section to act on. So let's have a look inside the control section again. So we start off in position 1, and you can see in position 1 we have the instruction address register is enabled and this bus 1 has gone high. So you can see here the instruction address register is enabled, so we're just passing on the values of 0 onto the bus. So this contains the memory location of the next instruction, which is just all zeros. So we've got all zeros sitting on the bus. We've also made this bus 1 go high. Now we've seen this in a previous video. Now all this does is when bus 1 goes high, it stops the normal flow of traffic from the temp register down into the ALU, and now the flow of traffic just comes from this value here, so it just simply puts a value of 1 into the ALU. Now the reason for doing that is that we're in effect getting ahead of the game here, because we know that the instruction address here is just a value of 0. We know that the next one will be a value of 1, and the one after that will be a value of 2 and 3 and 4. So what we're doing is we're getting a value of 1, which in effect is our next address for our instruction, and we're putting it into this ALU here. So we've got a value of 1 sitting there, and we've got a value of 0 sitting there, so all the way down this value just sits at 1. So this 1 eventually will be passed in and it will be our new instruction, the address of our new instruction. So again, it's just getting ahead of the game. So let's see what else happens at this stage here. So we can see here the memory address register is set, and also the accumulator is set whenever we get the clock set coming in. Okay, so it's memory address register and accumulator. So when the clock set goes high, we see the memory address register goes high and also the accumulator set goes high. So the memory address register going high, all that does is it puts the value of 000, which is sitting on our bus, which is the memory location of the next instruction. So that value 0 goes high, and we also have our accumulator going high here, so it just sets that value of 1 into the accumulator. So again, that's just part of the update of this instruction address register. So let's move on to the next step here. So we'll go on to step 2. So we'll just pulse it along. You can see that set is now gone low, so that value of 1 is held in the accumulator. So that's the next enable. So the next enable here, if I zoom down in, you can see here that the RAM's been enabled, so the value that was in the memory location 1 has now gone on to the bus via the RAM. Okay, and also whenever the set comes on, that value is going to be set in the instruction register. Okay, so all we've done here is we've enabled the RAM, so we've passed the value that is on the RAM, which is our 111. So we've gone into that memory location, pulled out the 111, and we've stuck it onto the RAM. And it's gone onto the RAM and all the way along here. And if we went into here, it says the instruction register has also been set. So you can see the instruction register would have been set. Well, sorry, it will be set whenever we go into the next clock pulse here. So go in the clock pulse here, and that's the clock set pulse. So the instruction register is set. So this value here, 111, which is the next instruction, has been placed inside the control section. Okay, so that's ostensibly what we want to do. We want to go and take the first instruction, which is in address 0, and put it into the instruction register, and that's what we've just done there just now. So finally, there's a couple of loose ends to tie up. So the next one is 0.3. So let's go along to 0.3. So the next enable clock of the clock comes in. So that's enable there. And we can see here that at that point here, what happens is the accumulator gets enabled and the instruction address register gets set. Okay, so the accumulator is enabled, so really what we're saying is we've taken this value 1, which will be the address of our next instruction, and we've taken out the accumulator and put it onto the bus. And then what we're going to do is we're going to put that value into the instruction address register, because that's the address of our next instruction. So whenever the clock set goes high, that value there would have been set, but you know, you've seen that before, I've already nobbled that, but that's that value going high, so that would be set in that instruction address register. So that's us worked through the 3 points here. So that's our fetch cycle, and of course if we were to continue with this, it would just, nothing's going to happen for the 4, 5 and 6, and then whenever this bus 1 goes high, that's us back to the beginning. And of course the value of 1 would then be incremented because we'd be adding another 1 onto it, and it would have a value of 2, 3, 4, 5, so on and so forth. So we'd be beginning and we would be pulling out the information that's in the next memory location there. So that is our fetch cycle. A lot involved in it, but you can take your time and mess about with this yourself and work through it yourself at your leisure. And if there's stuff you don't understand, I'm pretty sure after working through it a few times it'll become apparent what's happening. So that's all for this video. Thank you for listening. I'll get you in the next video. Goodbye.